Now we're adding the else clause to the if condition. Right, our new keyword else we'll be using, we'll have a group of statements we want to execute whenever this test condition is false. With the if statement, we checked if this test condition was true. So if this is true, we want to perform these actions. Else, when this was false, we want these actions to be performed. So those are two mutually exclusive actions. We don't have to retest the condition. Let's look at an example then with if and else. And I'm using compound statements in here. But once again, we're going to have some sort of test. And we're going to say, well, if this test is true, so if test, when that's true, we're going to execute statements 1 through 3 because they are inside these curly braces. These curly braces designate the group of compound statements because we have more than one, that we want to execute. So this is the action if block. Right, but when the test is false, we skip over this, and then we execute the statements in this block. So this is the action else block. We'd see statements 4, 5, and 6 printing out. Well, let's go ahead and bring up example 10 and take a look at that. So here's example 10. I'm going to add this to the project. I'm going to remove 9 from the project. It was up from a previous example. And all right, let's look at example 10. So here I've set test equal to 0. Right. We're going to see this run. We're going to see an output that says, that shouldn't say example 8, it should say example 10. Example 10, if else statements, right? We're going to be prompted to enter a value for the test condition. Right, so this just initialized test to some known condition. Depending on what value you put in, anytime you put a non-zero value in, this test here will be true, right? If this is a non-zero value, this will be considered true. We'll see these statements print out. And when this is true, we skip over this, end of our program. But now, if you were to enter 0 for test, you would see that this is false. If 0 is false, we skip over this, we'll see this print out. Let's go ahead and build and run. All right. So now then, enter a value for the test condition. Well, I'll enter 8. Remember, any non-zero number is true. So we see statement 1, 2, and 3 output. Right, now let's enter 0. So let's just go ahead and run this. We're going to enter 0, so we'll have a false condition, 0. Hit the enter. We see that we got statements 4, 5, and 6 as output. Right? Well, that gives you an idea of how to write something with an if and an else block. Once again, if you don't use curly braces here, only the one statement following the else condition will execute. You can see the good programming style that we're following here by indenting the actions that we want to take when this condition is true or when that condition was false. So now we're going to do practice exercise 2. We're going to modify practice exercise 1. And that program in practice exercise 1, we decided that we wanted to print out the message, you are eligible to vote, when someone is of age 18 or greater. So they're at least 18 years old. Remember, in example or practice exercise 1, we developed all of the code here in black, right? But now we're adding an else clause. We're modifying that by displaying a message that says that the person is not eligible to vote. So now, when this is false, we'll come down here and print this message, you are too young to vote, right? This is the branch that is executed when this test condition is false. Notice with each of these, there's only one statement associated with a true condition, this one statement associated with a false condition, because we did not use curly braces to enclose those statements in a block. Now that we know how to check test conditions, right, let's go back and think about scanf. We said that with scanf, it always returns an integer value. But we're relying on the user to always type information correctly at the keyboard. But what happens when they don't? Scanf fails, right? it returns, if we're trying to read one argument, it returns a value of 0. Now that we have an if statement, we can start checking that return value of scanf to know whether or not the user typed in good data. Good data in terms of the data type. Did we read something in? It still might be outside the range of values that we want to work with, but we'll just know whether or not scanf was able to read information and store it in our variable. Okay. Well, we're going to now do practice exercise 3. We'll add a condition to our eligible to vote program, right? We only check the age value when the program is successfully read, when the age is successfully read by scanf. Otherwise, if scanf can't read data because the user typed something it couldn't read, we say the scanf function fails to read the value entered, so we're going to actually then type out a message to do that. So we'll add on to the code that we had. So now let's see what we add. Well, up here in main, I've added another variable called return value. We're going to capture scanf's return value. We're going to store that information in this variable. Right, so we still have our same printf message. We want the user to enter their age. We're going to run the code, and we're going to then try and read in one item. Right, so we want to read in something for age. Remember, if scanf is able to read an integer value and store it in age, then it will return the number 1. Scanf will always tries to read one thing here based on this one specifier. So when you have one specifier, when it successfully reads, scanf successfully reads information and stores it in that memory location, it returns the number 1. But when it can't read anything and store that, it will return the number 0. Right. So here in green is the code we've added there. Right. Now we say if return value equals 1, meaning we successfully read something in and stored it in age. Now we can check to see, well, if you're of age, we'll do this. Else, if scanf failed, else down here, we print out the message, the age not successfully read. Why don't you go ahead and run this program and experiment with typing in good data and bad data and watch how the program flow works, see the output that you get. Use your debugger to check what's stored in memory, right, and how your program flow works. All right, now that we can use if and else, we want to make sure that they match. You have to be careful in the way that you write code, right? Else is always associated with the closest unassociated if. Let's look at this code. If x is not equal to 10, when this is true, we go ahead and execute this line of code. So when x is not equal to 10, we come down and check to see if x is greater than 3. Then we go ahead and perform division of z by 2, storing that back in z. So the only time this code executes is when x is not equal to 10 and y is greater than 3. Otherwise, when x is not equal to 10 and y is less than or equal to 3, we go ahead and execute this code. We multiply z by 2 because this else is associated with this if, right? So that's what we mean by else is always associated with the closest unassociated if. It's not because I indented this here. The indentation helps us read the code, and it helps us to know we expect this else to go with this if as well. And it does by default. Right? We could have written this code to be a little more clear by putting curly braces here. So if we put a curly brace here and here, we know that all these statements in here will only execute when x is not equal to 10. So when x is not equal to 10, we don't do either one of these. Right? But now, if x is not equal to 10, now we come in here, right, and we go ahead and check to see if x is equal to what or greater than 3. If it is, if y is greater than 3, we go ahead and divide z by 2. Else, if y is less than or equal to 3, we multiply z by 2. But this code and this code are the same. But this code is not the same as this because notice this order of operations. If x is not equal to 10, okay, when this is true, we come in and say, well, if x is greater than 3, go ahead and divide z by 2. But this says when x is not equal to 10, when that condition is false, we multiply z by 2. Well, that's not the way this executes. This only executes when x is not equal to 10 and y is less than or equal to 3. Only time we multiply z by 2 is when x is not equal to 10, y is less than or equal to 3. So these two are the same, this and that are not the same. So pay attention to which one of your ifs your else is associated with. Use these statement indicators here, right? This indicates the start of a block. This indicates the end of a block. We use those curly braces to make it clear what you expect to have execute. Right. Now we've seen if else. Now we can see if and else if. So we're going to test some additional conditions. Well, here then is our general syntax. Right. We're going to have our first test expression, just like we've seen before. Keyword F, if, IF, the test expression is inside parentheses. The way this flow works is if this test expression is true, we're going to do the statements inside of this first block. And then when this test is true, we skip over everything else and we would go down and execute statement Y. But now, if this test expression is not true, because of this else if condition, two separate words here, we come down and say, well, if this is false, come down and perform this test. When this test is true, it will execute the statements here in block 2, skip over these, right, and then come down and execute Y. The only time this else block executes is when this test expression is false and this test expression is false, right? So now you can see how we can test multiple things. And we might have multiple actions or different actions to take for different items, and we need to test multiple items. Right, so after you have that first if test expression, so after this first if, you can have as many else ifs as you want. Right. Reminder, good programming style uses braces and indentation to make it readable. All right, so now let's try a new practice problem. We want to write a program that determines whether the integer entered is positive, negative, or 0. So there's three things we're checking for. Is the integer positive? If not, is it negative? If not, is it 0? Three things to check for. All right, here we've got the code. Let's maybe back up a bit. Write a program that determines whether the integer entered is positive. Well, what do we need to do? We need input, process, and output. What's our input here? Our input must be the integer entered, right? That tells us they're going to enter information into the program. There's our input. Where are we going to get that input from? The keyboard. That's all we know so far is scanf. We're going to read some information and the user will type on the keyboard. Reading user information on the keyboard, that's how we get our input. Then what's our process? Well, we're not going to add or subtract or do any math to the numbers. Well, we might do some math, sorry. But we are going to check to see if a number is positive, negative, or 0. So we really don't need to do math. We can actually really just compare things to 0. Right? So we'll do some comparisons and then print out some information to let the user know whether it's positive, negative, or 0. Now let's look at the program. So we've got our input, our process, our output. Right. So here's practice problem 4. Right. We've got a variable here called value. I'm going to actually then prompt the user with the message, enter an integer. We want to let the user know what to do. Scanf then tries to read in the value they type and store it in the variable name value. Once that happens, then our program checks if the value is greater than 0. Well, the condition value greater than 0 is true for a positive integer. We print out the message positive integer. So when this is true, we'll see this message print out, and it will skip over this code, and then the program will end. But if they enter a value that's not positive, so this is false, we come down and say, well, is value less than 0? Negative numbers are less than 0. So when this is true, we'll print out the message negative integer. But now if this is not true, right, so if our number is 0, that makes this false, that makes this false. But by default, our number must be 0 if it's not positive or negative. We don't need to test here to see if it's equal to 0. So when both of these branches or these test conditions are false, we come down here and we just print out the message 0. All right, so go ahead, write that program for yourself. Go back a screen. Try not to look at the solution. Go ahead and write the program on your own and test it. Okay, now we want to be efficient sometimes, or always. All right. And so if we want to check multiple expressions, we test the most probable condition first to eliminate unnecessary tests. So think about it. If this was some code we were running, and if we were just checking to see what the month is, how many months out of our 12 months have 31 days? There are more months: January, March, May, July, August, October, December. There are 1, 2, 3, 4, 5, 6. There's 7 out of 12 months that have 31 days. The probability that the month will have 31 days is 7/12. That's the highest probability, because what's the next? A month with 30 days. There's 4 months with 30 days, so there's a 4/12 probability. There's 1 month that has 28 or 29, depending on leap year, right? So that has a probability of 1/12. Then we also have to account for the fact that the user could type a number in that is beyond the range of months. We're just going to assume that that's a low probability. So to be really efficient now, if we were to check for a month with 31 days, and the user always typed in good information, we'd have a 7/12 probability. So we'll check for that first, right? So that we can not have to perform all these other tests, right? If we waited till last, we'd have to perform this test, and then this test, and then these tests. So we're being efficient by checking this first, because when this is true 7/12 of the time, we'll print out the month has 31 days. We'll skip over this test condition, and this branch as well, right, when one of these is true. Otherwise, if the month has 30 days, well, we do have to perform all of these comparisons. And then we have to come through and perform these comparisons. As soon as one of these is true, we'll execute this statement, this printf, and print out month has 30 days, then skip over this, and then skip over this branch. Finally, now when this is false and this is false, we come down to check, well, is the month equal to 2? Is it February? When this is true, we print out this message. Otherwise, this only happens when all of those other tests are false. So here, once again, I'm assuming that most of the time the user enters a correct month name, and that will have the highest probability that it will be one of these months. Just talking a little bit about efficiency there. We'll start talking about it more. All right, our next topic in the next set of videos will be on the switch statements. But that concludes if and else if.